Let's take a look at the mechanism whereby we develop elevated CRP or inflammation, and the mechanism whereby an elevated CRP or chronic inflammation leads to short lifespan and other problems with health. Inflammation is designed to fight foreign invaders. And for acute infections, inflammation is good. It protects us against pathogens. The problem is chronic inflammation, measured by CRP. Higher the CRP, higher the body's state of chronic inflammation. There's several pathways whereby we develop elevated CRP or inflammation. Let's start with nutrition. So a diet low in fiber, low in omega-3s, low in intake of antioxidants, and high in intake of pro-oxidants leads to reactive oxygen species, which damage cells. Damaged cells are sensed by the body's immune system as foreign invaders, triggering an immune response. So if I have lots of fruits and vegetables, I'm eating lots of antioxidants. Antioxidants have extra electrons, which they donate to reactive oxygen species or free radicals. They actually will prevent inflammation. Pro-oxidants like heme iron in red meat, like alcohol, like nitrites in processed meat, they carry along with them free radicals, which are molecules that are missing an electron. And when they get into the body, they aim to grab electrons from healthy cells to stabilize their structure. And that causes damage to the body's cells, which triggers inflammation. The ratio of omega-3s to omega-6s in the fat we eat in our diet is also important. You want a high level of omega-3s and a low level of omega-6s. Omega-3s come from foods such as seafood, omega-3 rich sources of seafood, salmon, mackerel, anchovies, sardines, herring. And damaged cells in the body are cleared from the colon when we have a diet that's high in fiber. When we have a diet that's low in fiber, damaged cells can lie against the border of the intestines, causing damage to neighboring healthy cells. Fiber is a way of cleaning out damaged cells. So these are the dietary factors in general that promote inflammation on the one hand, and those that reduce inflammation on the other hand. Abdominal fat is another source of inflammation. Amazingly, fat tissue is hormonally active. We once thought of fat as just a storage place for energy, but it actually sends out distress signals. The fat that's most significantly hormonally active is belly fat, which is why belly fat is associated with higher inflammation and higher risks of inflammation-related diseases like diabetes. And finally, we can look at inflammation as occurring when we become insensitive to cortisol. So when we are sleep deprived chronically, when we are under chronic stress, when we are under chronic anxiety, when we are depressed, lonely, socially isolated, these are states of heightened arousal. Heightened arousal is activation of the sympathetic nervous system. Activation of the sympathetic nervous system results in elevated levels of cortisol, a stress hormone. Cortisol is important because it tamps down the immune response. It helps regulate inflammation and our immune response. But in states of chronic stress to the body, as described, we have elevated cortisol. The body becomes insensitive because there's always cortisol now around. It no longer responds to it. So the natural check on the immune system, the natural brakes on the immune system have been removed when we're under chronic stress and become cortisol insensitive. Those are some of the basic causal factors for chronic inflammation and elevated CRP. What's the downstream effect of chronic inflammation and elevated CRP? Well, because inflammation is so central to the aging process and to diseases of aging, it's been termed inflammaging. That's how closely related inflammation is to the process of aging and the process of onset and progression of chronic diseases. I'll give you one example and then we'll do an overview of all the other effects of aging throughout the body. In heart disease, we know it develops not just when you have elevated LDL cholesterol. There has to first be endothelial dysfunction, meaning the walls of the arteries to the heart and in the brain become dysfunctional. And that means that they become permeable. They allow cholesterol and other inflammatory cells into the arterial wall. This leads to the ability for a fatty streak to develop in the artery, which then becomes a plaque, which then becomes a blockage to the heart or brain, causing heart attacks and stroke. But the endothelial dysfunction is a result of inflammation, and the progression of the plaque is a result of inflammation. But that's not all inflammation does. Inflammation is at the root of practically all known chronic health conditions. In the brain, it can cause depression, memory loss, Alzheimer's disease, multiple sclerosis. In the skin, it can result in wrinkles, rashes, eczema. In the heart, as we've already said, it can lead to heart disease, stroke, even diabetes. In the kidneys, it can lead to high blood pressure and nephritis or kidney inflammation. In the bones, it can lead to bone loss and osteoporosis. In the liver, it can lead to fatty liver disease. In the thyroid, it can lead to thyroid dysfunction, inflammation. In the lungs, it can lead to allergies, autoimmune reactions in our airways, and asthma. In the GI tract, it can lead to gastroesophageal disease, Crohn's, and celiac. In muscle, it can lead to joint problems from carpal tunnel to polymyalgia rheumatica. It's hard to name a chronic disease or condition that isn't directly caused by or made worse by inflammation in the body. So we've seen now the major causes of inflammation or elevated CRP and the major consequences of inflammation or elevated CRP.